All right, 8.5, add and subtract rational expressions. So we did our mini quiz on like A, so if you want to go back and do A, you can do A later. Let's talk about B and C here in the warm-up. Let's do those together. So to add and subtract fractions, what do we have to have?
Common denominator.
Common denominator. So the easiest way to find the common denominator, okay, it might not be the least common denominator. Things are easier if you can find the least common denominator. But worst case scenario, you forget, you just take and multiply each fraction by the other denominator, right? So now, this is a 5 and I need to get to 15. So I got to multiply this side by, well, the right side, I just do that one first. So by 3. Now, to keep this the same, if I multiply the bottom by 3, I also have to multiply the top by 3. What am I really multiplying by there? What's 3 divided by 3? 1. You're really multiplying by 1. 3 divided by 3 is what? 1. So does multiplying by 1 change anything? No. So it's still going to have the same value. It's going to look different, but it has the same value. Because if I wanted to, I'm not going to do it. But when I multiply them all out, if I multiply this out, I'm going to get 3 over 15. Well, if I reduce this back, what does this reduce back to? Divide them each by 3 to get back to 1/5, right? So it's the same value, just looks a little different. Okay, what about the other one? 2/3, I'm going to have to multiply by what? Yeah, the other denominator, 5 over 5. I have to do the top and bottom, multiply both of them, so I'm really multiplying by 1. Okay, if I do just the bottom, it changes the value. So this is going to be 10/15. The reason why I have to do that is so I can, when I add them together, the 15ths isn't necessarily, it's kind of giving me a, kind of like a unit of measure, saying how much of a whole is it. So I don't know how many total parts of a whole do I have. We're talking about fractions. It's like, so if you have like, I don't know, pops. You go to the store, you can get a 20 ounce, you can get a liter, you can get a 2 liter, right? So if I get a 20 ounce and a liter and I add them together, does that give me 2 liters? No, because they're different denominations, right? They're counting by different amounts. Same with fractions, it's the same thing. Because I have 1 plus 1, it doesn't equal 2 liters. Because we're talking about different units. Same with fractions. If I did 2/3 plus 1/5, I can't add those because they're not like units. I have to get them into like units by getting the denominator the same. How many parts of the whole is 2/3? Well, if we're talking, we need to get it into 15ths. So they're similar. So they're common denominators. So they're counting by the same things. Same unit of measure, if you will. So what's 10/15ths plus 3/15ths? Yeah, leave the bottom the same and just add the top. Because it's how many? I have 13/15ths altogether. And like I said, the 15th isn't talking about how many of them I have, it's how much of the whole, what portion of the whole do I have. So C is going to be similar. I do the same thing. Common denominator, well, these are the same two fractions. The only difference is we're doing what? Subtracting them now. So when I get to here, I have 10/15ths. And then I have minus 3/15ths. So when we're subtracting, what do? Same thing. You leave the denominator the same, and you just subtract the numerators. 10 minus 3 is 7/15ths. Okay? We good with that? Today we're going to do it, but we're going to do it not with numbers, but we're going to do them with variable expressions. Okay? So, add and subtracting rational expressions. So, first thing you need to do is get a common denominator. So, what you're going to have to do, or one thing that'll make it easier, is to factor. So you can see, okay, what is this made up of? Okay, and then you're going to find the least common denominator. Then you add and subtract the numerators. Be careful when you're subtracting. If you have more than one term that you're subtracting, you have to make sure and take that subtraction to each of those. So you're going to have to take the subtraction sign to each. Okay, or make sure you subtract each. And then you reduce or simplify your final answer. Alright, so for the first example here. Well, why is this one nice? It already has a common denominator, right? So I don't have to get another common denominator. So, all I'm going to do is, since the denominator is already the same, I can just go ahead and do my subtraction. You just subtract the numerators and leave the denominator the same. So this is going to end up being what? 2x minus 2 over x minus 1. The denominator stays the same, and then you just subtract in this case, subtract the numerator. 2x minus 2. So, now it said last is reduce, simplify. Can I reduce or simplify that? So can I factor either of those? Factor the top, does it help? Well, it might. So if I take a 2 out, does that? Right, 2x minus 2 factors into 2 times x minus 1. Then I have an x minus 1 there. So can I reduce anything? Yeah, what can I reduce? Can I reduce the x minus 1s. So what am I left with? Okay, so that one reduces quite a bit. Next one. So now I have two different expressions on the bottom. So you're going to look at the coefficients, but also the variables. So what is the common denominator of the coefficients? 2 and 10. 2 and 5. 10. My brain was thinking. So 10. So what do I have to multiply 5 by to get to 10? 2. If I do it on the bottom, I also have to do it on the top. Okay? So what do I have to multiply 2 by to get to 10? 5. So if I do the bottom, I also have to do the top. So I took care of the coefficients. Now I need to get my variables to be the same. Anybody know what the common denominator of x squared and x is? You could go to x cubed, but it makes things, you want the least common. So remember, x squared is really what? X times x. And this is just x. So this already has 2 x's. So all I have to do in the second one is multiply this one by x to get to x squared. So I can get to x squared by multiplying this, the 2x by x. So I do it to the bottom, I also have to do it to the what? Top. So if we're talking about powers, if I can just multiply by more x's to get to the other power, that's all I have to do. Okay? Now, if it was like x squared and x cubed, okay, well, you just multiply by the x squared by an x to get to x cubed, right? It's not, just got to figure out, okay, how many less does it have? And multiply by that many to get it to that. All right, so when I do this, this first fraction is going to end up being what? 24 over 10x squared minus, what's the other fraction going to end up being? 16x over 10x squared. So do I have a common denominator there? Yeah. So now I can just go ahead and do my subtraction. So this is just going to end up with what? 24 minus 15x over 10x squared. So now, can I factor? So how do I factor the top? Can I factor the top? You can take out a common factor of 3, right? 3 goes into 24 8 times. 3 goes into 15 5 times. 10x squared is only a single term, so I can't factor it. If there's only one term there, it doesn't factor. So does that reduce it all? No. So you can either give either one of these two as your answer. This, or if you want to leave it in factored form, or it doesn't matter. But you should always try and factor and see if it can reduce it at all. So either one of those would be acceptable. Okay? Questions do we have on that? Do we understand how to get the common factor when we have variables like that? All right, next one. So this is kind of like the practice we did. If I just had, let's say I just had 2 and 3 as my denominators. So what would I have to do to get a common denominator in that case? Well, you multiply the 2 by 3 and multiply the 3 by 2, right? We're going to do the same thing, but in this case we're going to do it as what? Not just 2, we're going to do what? X minus 2 over, or excuse me, x plus 3, and multiply by the other one. X plus 3 on this side. If I do it to the bottom, I have to do it to the top. Now, it might be helpful to use parentheses here so you know what to do when you go to multiply them. Over here, what am I going to multiply by? X minus 2 on bottom and x minus 2 on top. So on the left side, what does my new fraction end up being? Well, how do I multiply x plus 3 times 4? The top you want to simplify so you can combine like terms. The bottom, I would leave it as factored form. I wouldn't multiply the bottoms together. Leave them factored because we're going to have to factor later to see if they reduce. So leave them factored. Okay? So how do I multiply these two together? I'm going to distribute, right? So what am I going to get when I distribute?
4x plus 12.
4x plus 12. And then the denominator is going to be x plus 3 times x minus 2. Okay, so that's the first one. Second one, well, I want to multiply the tops together so I can simplify. So when I do that, what do I get there? 2x squared minus 4x. Right? 2x times x is 2x squared. 2x times negative 2 is negative 4x. And the bottom, I'm just going to leave it again as x plus 3 times x minus 2. So now, do I have a common denominator there? Yeah. So what do I do once I have a common denominator? Careful, we're not technically solving, we're going to simplify, right? What can I simplify though? Only the what? Numerator, right? So to simplify this, we're going to combine like terms. We do 4x plus 12 plus all this. Now, if this was a subtraction sign, we'd have to make sure to what? Take that subtraction to each on top. Okay, but addition, I don't have to worry about distributing an addition, because it doesn't change anything. So what are my like terms on top? Start with the highest power term, because it's easier later on down the road to write it in standard form. So what's the highest power term there? The x squared, right? So I have 2x squared. I don't have anything else. Okay, now what about my x's? Go down the list. 4x plus negative 4x. Cancel. So I don't have any more x's. 4x plus negative 4x, 0 x's. Gone. And then just plus 4. Okay. Over x plus 3 times x minus 2. Does that make sense? Okay, so now I'm going to try and reduce if I can. Well, what can I do to factor the top? Take a 2 out. So I'd end up with x squared plus 6. So, did that help me at all? No, because x squared plus 6, I can't factor that at all, right? Because it's a sum. And 6 isn't a perfect square either. So. Alright, so I can't do any of that. So I have either I would probably just circle this as my answer, but if you circle that, that's fine also. Okay? Yes.
What would happen if before you add them, you factored?
But then you need to be able to combine like terms. So when you factor them, you can't combine like terms.
Oh, so
So you don't want to factor until after you combine like terms. Yep. Because to be able to add them, we need to have them all in both in standard form. All right, what questions do we have on that? All right, next one. Okay, this one kind of takes up a little room, they give you a whole lot. So, first thing we got to do, I can't look at this and determine the common denominator yet, because this is made up of probably a couple different types of things. So what I have to do is I have to factor both of those. So, how do I factor x squared plus 4x? So what's the bottom going to factor into? Yep. So x. So we ask what multiplies the 4 and adds the 4. So to multiply to 4, multiply to a positive and add to a positive, they both have to be positive. So what are the factors of 4 that add to 4? 2 and 2. So, do I have a common denominator there? That's part of it, right? The one on the right has an x plus 2. The one on the left has what? 2x plus 2's, right? So on the right, I need one more. So what I'm going to do over here is what? Multiply by, I need another x plus 2, right? Yes.
So you don't always need to do anything on the other side.
Nope. Sometimes you don't have, if it's already, if I can multiply only one side by something to get to it, then just do the one. Don't make it more complicated than you have to. Alright, so this ends up being x plus 1 over x plus 2 times x plus 2. Plus, over here, when I multiply this, how do I multiply 7 times x plus 2? I get what? Distribute. So it's going to be 7x plus 14 all over x plus 2, and then times that other x plus 2. So now I have my common denominator. So again, this is addition. If it was subtraction, what would I have to make sure to do first? Distribute the subtraction to each.
Only the numerator.
Only the numerator. Only the one that's being subtracted. Okay, but it's not its addition, so I can just do what? Just add them. Combine the like terms just like they are. So it's x over the highest power term would be x. X plus 7x. X. And then 1 plus 14. 8x plus 15. All over 2 times x plus 2. So, can I factor that at all? Top, bottom's already factored. 8x plus 15. Well, those are common, no, 8 and 15, there's nothing in common. So that's, ours and right there. Okay, so that's how we add and subtract. Now the next one we're going to talk about are complex fractions. So what a complex fraction is a fraction inside of a fraction. So, can't have that, so, okay? You guys like fractions enough without having to have fractions inside of fractions. Right? So what we're going to do is we're going to get rid of a fraction inside of a fraction. We're going to get just to a single fraction. Okay? So to do that, we need to eliminate the denominators. So what you're going to do is come up with the least common denominator of all of the denominators we have. Okay? Then we're going to multiply everything by that least common denominator. And that will eliminate any of the denominators that we have. And then we just simplify what's left. Okay? So we need to come up with the least common denominator looking at all the denominators we have. So in this first example, what are my denominators? What denominators do I have there? Careful. So that is in the denominator of the bigger fraction. Now we're going to look at each individual fraction and just look at the denominators of those. So the smaller individual fractions, the denominators are what? 6, 3, 5, 10. Okay, so what is the least common denominator? What number do all of those go into? Smallest one. Yeah, 30. Easier if you do the smallest one. Least common denominator. The least common one. So 30. Does 6 go into 30? Yeah. Does 3 go into 30? Yeah. 5? Yeah. 10? Yeah. So they all go into 30. So what I'm going to do is I'm going to multiply everything by 30. So now, hopefully what we can do, we can look at this and say, okay, well, if I were to kind of rearrange this, this is 30 times x over 6. So I can take and reduce those. So what is 30 divided by 6? 5. So really I'm left with 5 times x. Okay, so this is really just going to be 5x there. The first one. Okay, minus the next one. Look at these. What is 30 divided by 3? 10. So it's really going to be 10 times x. 10x. Here, what's 30 divided by 5? 6. So this is really going to be 6 times x. Minus what's 10 divided, or 30 divided by 10? 3. So it's 3 times 7. What's 3 times 7? 21. Everybody see that? So now I got rid of all the fractions. I only have one single fraction instead of having 4 fractions inside of another fraction. Okay, so we came up with the common denominator, least common denominator, and multiplied everything by that. I got rid of all those fractions. So now I'm just going to simplify this. So on top, what's 5x minus 10x? 5x. On the bottom, can I simplify that? I got an x term and a constant, so I can't simplify. Well, I could factor what? 3 out of the bottom. Does that help me at all? 2x minus 7. Negative 5. Can I? No, can't simplify anything there. So either one of those last two would be appropriate. Yes, sir.
So with these, with the first step is you find the least common denominator.
Yep.
Then you just like cross.
Then you multiply each of those by that, and then really what I'm doing, I'm just saving some steps. This is really just what? Would be 30x divided by 6 minus 30x divided by 3 all over 30x divided by 5. If I were to multiply these out, minus 210 divided by 10. Right? That's really what I'm doing. And now to simplify these, you do what? 30 over 6 backwards. That makes sense? They just save in a step instead of having to do that and then divide. I just kind of did it at once. That makes sense?
Yeah.
What questions do you have on this? Anything else? All right, now this one. Oh, there's only one denominator. What's the only denominator? Well, we got the denominator of the bigger one. What's the only denominator of the smaller fractions? Alright. So, it's the least common denominator. So I'm going to take and multiply everything by x. So when I do that, so what happens over here? Well, I'm multiplying by x and dividing by x, so those what? Cancel. So what am I left with there? 2 minus, well, it's just 4 times x, which is what? 4x. All over. What am I going to end up with on the bottom? 2 cancel, right? 2 plus. Okay, cancel those 2's because of why? I'm adding and subtracting them to something, not multiplying. Okay? I could try to do this, factor a 2 out there. If I can factor a 2 out on the bottom, then I could cancel the 2's out front that I'm multiplying by, but can I factor a 2 out on the bottom? No. So I can't cancel. I can't cancel these because I'm adding and subtracting. Like right there, I can't cancel those because I'm adding and subtracting. Now, like I said, if I could factor a 2 out of each, like if I ended up with something like this, then I could cancel those 2's out. Because it's 2 times and 2 times. But here, because I'm adding and subtracting, I cannot cancel those. Okay? That makes sense? See the difference between these 2, I can cancel here, but not here. This is a 2 times something, 2 times something. So we can just divide, but this is 2 minus and 2 plus. Alright, so to add and subtract, we need the least common denominator, Okay? So to do that, sometimes you got to factor. Okay, and then multiply. Make sure if you multiply the bottom, you put a common denominator, and I also have to multiply the top. Really what you're multiplying by is something divided by itself, which is just 1. So it's not changing the value, it's just making it look a little different. Okay? You have complex fractions, fractions inside of fractions, come up with a common denominator, multiply everything by that, and then simplify. Okay?